Hello everybody, this is Dr. Eldik, and today we'll talk about chapter 4 in circuit. Chapter 4 is just to give you some or introduce some circuit theorems that can be used in some, for example, some situations. Any circuit can be solved using the two techniques we learned in chapter 3. So we have nodal analysis or mesh analysis. So if I ask you from now on, how do I solve this circuit? Okay, it is just nodal analysis or mesh analysis. The techniques that we will learn in this chapter are used in some situations. For example, we have something called superposition, linearity, so source transformation, Thevenin and Norton, and maximum power transfer. Let us see what superposition. Superposition simply says that, let me show you this example to make it easier. Okay, imagine that you have a circuit like this. And if I want to ask you to calculate, for example, the voltage across this 3 ohm. Okay, so of course you can solve it using nodal analysis or mesh analysis as I explained before. But in some cases, sometimes you may need to use this superposition if you have multiple sources. So here I have 40 volt, I have 2 ampere, I have 4 ampere. So I have 3 sources. So superposition say what? Says that the total voltage across this 3 ohm, this V0, equal the total voltage of or the effect of these 3 sources. So if you take the effect of each source individually, so I need the effect of the 40 volt alone, and then after that 2 ampere, then after that 2 ampere only. Then if I add these 3 effects, this will be the total voltage across the 3 ohm or VO. So this means what? Means that you, for example, you keep, for example, the 4 ampere, and you turn off the other sources. You turn off all other sources. And then you keep the 40 volt and turn off all other sources, and so on. And then you keep the 2 ampere and turn off the other sources, and so on. So every time you turn on one source and you turn off all other sources. So this is superposition. So, but the question here, how can I turn off the source? What's the meaning of turning off the source? In the lab, it's very easy. You just turn off the source. It's very easy. But in a circuit, if I have a circuit like this, what is the meaning of turning off a source? Turning off a source, if it is a voltage source, you replace it by short circuit. And if it is a current source, you replace it by open circuit. That's it. Okay. So for example, let us keep the 4 ampere. This 4 ampere. So here is a 4 ampere. And I want to turn off the 40 volt and the 2 ampere. 40 volt is a voltage source, so you replace it by short circuit. Here it is. This is a short circuit. And the 2 ampere is a current source. You replace it by open circuit. Open circuit means it's open. It's open here, between these 2 points here, from here to here. So you can either just remove it, or you can replace it by open, just open. But you can just easily, you can remove it. That's it. Open circuit means remove it. So here, if you look at this circuit has only one source. So I'm taking the effect of the 4 ampere only. Okay, so in this case, the voltage that you calculate across the 3 ohm is V01, is V0 due to the source number 1. And then you do the same for the other source. I keep, for example, the 40 volt source. Here it is. And then I turn off the other sources. For example, the 4 ampere, this is a current source. You replace it by open circuit, which means that you remove this. So here it is. You don't have it here. And the 2 ampere, you replace it by open circuit. So you remove it like this. Okay, so now I have only the 40 volt. Then I calculate the voltage across the 3 ohm. In this case, it is V02 because it is V0 due to source number 2. Then you do the same for the third source. Then you keep only the 2 ampere and you turn off the other sources. So the 40 volt, you turn off the volt source. 40 volt is a volt source. You replace it by short circuit. So here it is. You see the 40 volt, you replace it by short circuit. And the 4 amperes, this 4 ampere, you replace it by open circuit because it is a current source. So here it is. You don't see it. It is removed. So now I calculate the voltage across the 3 ohm. In this case, it's called V03 because it is V0 due to source number 3. Okay. Then in this case, the total voltage when you have all sources, okay, in the original circuit equal what? Equal V01 plus V02 plus V03. Okay, so imagine, for example, somebody can say, okay, in this case, this means that I will do the calculation 3 times. So sometimes, yes, it makes sense. It doesn't make sense that you do that. But assume that, for example, that you are in the lab and you have only one source, okay, and you have a circuit that has multiple sources. Then you can use superposition to do the measurements. So you can turn off all the sources and use only one source at a time. Because if you have only one source, so how do you do the experiment, for example? You can use the superposition in this case. Same for this one. If you look at this example here, you have 3 sources. You have 24 volt, you have 38 volt, and you have 4 ampere source. So if you keep, for example, the 24 volt, you turn off this one. This one is gone because it is removed, open circuit, and this one is short circuit. Here it is. So this is the circuit after you turn off the other sources. You keep only the 24. If you keep the 4 ampere source, here it is, you turn off the voltage source, so it's short circuit, the 24 volt source, and the 38 volt source is also short circuit. Same for the 38 volt. If you keep the 38 volt only, then in this case you turn off the current source, 4 ampere is gone, 4 amperes was here, you remove it, and you turn off the 24 volt short circuit. Then you calculate the voltage, whatever required voltage here is the voltage across this 5 ohm. So here is V01, here it is V02, and here is V03. Then the total voltage when all sources exist is what is total is V01 plus 2 plus 3 and so on. So this is simply the superposition. The second theory is called linearity. Linearity means what? Linearity means that if you multiply, for example, all the sources by number, then you multiply the result by the same number. For example, assume that you have this circuit here, this circuit, and you have the source 4 ampere, and then you calculate the voltage, this IO. Okay, you want to calculate this IO. If IO is if when IN is 4 ampere, IO is 1 ampere. Is 1 ampere, yes. So if this one is 4, this one is 1. Okay, we agree? Now, what will happen if I doubled the current source? Or doubled, of course, in this case, if you have multiple sources, you double all the sources. What will happen if I doubled all the sources? What happened? That the results will be doubled also. So in this case, if IO will be what? If IN is 8, IO will be 2 ampere. Instead of 1, will be 2. If IN is 12 ampere, then in this case, IO will be 3 ampere, and so on. So here it is, you see, from this table, if IN is multiplied by by number, you multiply O by the same number. 4 to 6, you multiply by 1.5. So you multiply IO also by 1.5. If it is multiplied by 2 here, from 4 to 8, you multiply the output also by 2. If you multiply this by 3, you multiply IO by 3. At the end, the relation between IO and IN is constant. You see, it is 1/4. IO divided by IN is constant. Cannot be different number. Cannot be 0.25 here and here is 0.5 or 0.3. No, must be 0.25. And this was the meaning of linearity. So, for example, if I give you a circuit like this one here, like let's see here. For example, this circuit here. Okay. For example, assume that VO is 1 volt. Okay, Assume when I calculate VO is 1 volt. It is not 1 volt, but assume if it is 1 volt. Okay. So now if I ask you, okay, I want this 1 volt VO to be 2 volt, to be 2 volt. So what do you want to do to make it 2 volt? Instead of 1, you make it 2. This means that you multiply all the sources by 2, which means that instead of 40 volt, you make it 40 times 2 will be 80 volt. And instead of 2 ampere, you make it 4 ampere. And instead of 4 ampere, you make it 8 ampere, and so on. So this is the linearity. This is the linearity. Second or third theorem here is called source transformation. Source transformation. And source transformation is useful when you have, for example, assume that you want to transfer a voltage source to current source or a current source to voltage source. We know that we don't have a current source in reality, so we don't have this current source. So if, for example, you have a circuit in current source and you want to do it in the lab, you need to convert it to current to voltage source. But there's a condition to do that. You can't just convert any current source to voltage source or the opposite. There's a condition. What's the condition? The condition is that the current source must be parallel to a resistor. Parallel to a resistor. Okay, when you convert it to a voltage source series with the same resistor. The same resistor. Okay, so these two are equivalent to each other. Okay, so here's R, here's R. But the current source is parallel with the resistor. The voltage source is series with the same resistor. And when you convert, the relation between the voltage and current is very simple, just Ohm's law. So if you want to calculate the voltage, this Vs, for example, if you want to convert this one to this one here, Vs equal what? Vs equal R times I. Okay, and if you want to calculate, you convert this one to this one. If you want to calculate Is is V divided by R using Ohm's law. That's it. That's it. Very simple. Then, for example, if you look at this source here, this is a voltage source in series with the 2 ohm, 5 volt series with 2 ohm. So in this case, you can convert it to current source parallel with the same resistor. The same resistor here is 2 ohm. That's it. Okay, but what is the current? The current, you follow Ohm's law. And if you can't remember Ohm's law, remember Ohm's law is just like this. There it is. Ohm's law. V-I-R. Okay. So in this case, you just, if you want to calculate the voltage, multiply. If you want to calculate the current, divide V over R. So here, 5 divided by 2 will be 2.5. And if you want to do the opposite, for example, if you have a current source like this one here, this 4 ampere and 3 ohm, they are parallel to each other. Then you can convert it to voltage source series with the same resistors. Then 3 ohm is 3 ohm. You don't change it. And this 12 volt is coming from Ohm's law. So you multiply 2 times 4, 3 times 4 would be 12 volt. So this is the idea. So source transformation, that you convert a voltage source to current source or the opposite, but the condition is that the voltage source is in series with the resistor and the current source is parallel with the same resistor. So for example, if you have a circuit like this, in this case you have how many sources here? You have 1, 2, 3. You have 3 sources. Okay. You can't convert any source. For example, you have this 5 volt. You see this 5 volt? You can't see, you cannot convert this 5 volt. Why? Because this 5 volt is not connected in series with a resistor. In series with a resistor. But for example, here, if you look at these two together here, okay, 5 ampere in series with, in parallel with 6 ohm. Parallel with 6 ohm. Then you can convert them to voltage source in series with 6 ohm. But you convert them, and when you connect them between the same 2 points. You see these two are the same 2 points. So here's the first point, here's the second point. So here's the first point, here's the second point, and this is equivalent to what? The same resistor, 6 ohm, and the voltage source is what? Is 30 volt. Why 30 volt? Because it's just 6 times 5. 6 times 5. For these two here, you have a current source, 3 ampere, parallel with what? It's not parallel with 4, it is parallel with 4 and 1. So 4 and 1 is 5. So actually this is 3 ohm, 3 ampere parallel with 5 ohm. Then you can convert these two to a voltage source in series with resistor between the same two blue nodes here, this one and this one. So you have this 5 ohm, and the voltage equal what? Equal 3 times 5, which is 15 volt. So now you have this circuit, okay? Now you have this circuit. You convert this one to this one. So assume, for example, that you have this circuit in the lab and you want to do it. You don't have a current source. So in this case, you can do it like this way, okay? And so on. If you try to see if you can convert any other source. So for this circuit, you cannot convert any other circuit because you do not have another source that can be converted. Because you don't want to convert this back. Of course, you need to convert something else. Okay, and so on. So this is the third theorem in circuit.